And question 6 asks if this argument is valid. So as usual, we want to negate the conclusion. The lines 1, 2, and 3, I'll set up my tree. And let's see, first thing, maybe I'll get rid of this double negation in line 3. Well, x, g, x, arrow exists, y, f, y. That came from line 3 using the double negation rule. And now I have FA in line 1, and I've got two universals in lines 2 and 4. So all I can do now is start decomposing those universals. I'll start with line 2, and I'll apply that to the variable I have, which is A. So now I've got FA arrow GA. So that is line 5 coming from line 2 with the universal applied to A. And I'll apply that to the variable A. Let's see. I wouldn't usually do a branching rule straight away, but I can see that if I do the branching rule for this arrow, I'm going to be able to close one of the branches using FA at the top. So I'm going to do that right away. So I'd have negation FA and GA over here. And I can see immediately that this contradicts with line 1, so I can close that branch. Line 6 came from line 5 using the arrow rule. And I can take that off. And so now I still have A that I can apply to the universal in row 4. So for all x, gx, arrow this way fy, I'll apply that to A, and get ga, arrow exists y fy, and I've applied that to A. And I can see again that if I, oh sorry, that came from line 4 using the universal on the variable A. And I can see that if I deal with this arrow straight away, that'll help. I've got negation GA, which is a contradiction with the line over here. And I've got exists YFY. That was line 7 coming from this was line 7, and this was line 8 coming from line 7 with the arrow rule. So now what have I got left to decompose? I have just this one, exists y fy. So remember, I have to use a variable that hasn't been used on the branch before, so I'm going to use b. So I've got fb. Right, is this branch open? Yep, it's still open. I forgot to take that one off, sorry. It's still open, but is it complete? Sorry, I'm being a bit confusing. Let's just write down the notes for this last line up here. I've got line 9, and that came from line 8 using the existential rule and the variable b. So back to what I was saying, I'm just wondering if this branch is open. Yep, it's open, there's no contradictions on it, but is it complete? Well, it's not complete yet because now I have this variable b, and these two lines 2 and 4, they won't be decomposed fully until I've applied them to every name that's on the branch. And now I have b on the branch, so now I have to apply them to b as well. So let's start with number 2. I'll apply that to b, and that gives me fb, arrow gb. That was line 10, coming from line 2, universal applied to b. And I can do my arrow straight away because, I took that off. Oh, sorry, I can do my arrow straight away because I can get negation of FB and GB over here, which is line 11 coming from line 10 using the arrow rule, and I can tick that off. And now I can close this branch because I've got a contradiction with FB and not FB. And I can go with GB over here. And right, I still need to apply b to this universal over here. I'm going to do that. I get GB arrow exists y f y, and that is line 12 coming from line 4 applied with the universal applied to b. And now I've got this arrow to deal with, and I'm going to do that straight away. I get negation of GB on this branch, which I can close straight away, and exists y f y on this branch. And I've got that's line 13 coming from line 12 with the arrow rule. And I am nearing the end of my page, and also I'm starting to notice a pattern, because if I'm going to keep going and decompose this branch, I've got exists y f y, and I have to use a new variable, because exists means I can't reuse one I've already got, so I'm going to have to go something like fc, line 14 coming from line 13 with the existential applied to a new variable c. And I don't know if you can tell, but I can tell that there's a repeating pattern going on here. I keep having to generate new variables that that go along with which I can apply, which f is true of, and then that makes g have to be true of them, which makes them have to generate another variable with f on it. So if I kept going with c, I'd eventually get gc and then another exists y f y. It's just going to keep going. So I've picked up that this tree is not going to close. It's an infinite tree. So what do I do in this situation? Well, we can tell that there's an infinite model which makes all the roots of the tree true together. So there's basically an infinitely long open branch. But gladly, what I can say is if we have an infinite open branch, there is also going to be a finite open branch. So what we're going to do is try and make a finite one. In fact, try and make sort of the smallest one possible so that it'll be easier to evaluate. So the way we do that is we try go back to where the trouble started. So we try go back to before the loop was generated. So over here, this sort of means I'm going back to before we made b, because that was that was sort of when the loop started. So we look above this point and try creatively construct a model that has we try creatively construct a model where the roots are true. So I'll clear those away, and what we have to do is just look at all the information on this branch that we have already and construct a model with those things being true. So I'm going to say my domain has A in it, and what do we know about A? Well, let's fill in the predicates we know so far, fx and gx. Well, fx, if A is true, and gx, we've got GA being true as well. And so, yeah, let's see if this is going to be enough, if this domain by itself is going to be enough to make the roots true. So my roots are FA, all x, fx, arrow gx, and negation, all x, gx implies exists y fy. And we'll do a partial truth table over here. And so the variables that are used in these formulas are x and y. And the only possible combination of A's for X and Y is A and A. Now if we had B's as well, then it would have to be A B, BA and BB. Or if there were C's, there would be even more combinations, but with what we've got, A and A are the only possible combinations for X and Y. With FA, we can read off the table that it's true. Fx over here, well, X is A, so we have FA, and that is true from the table over here. Same for Gx is GA, which is true, so that makes this arrow true. So Fx arrow Gx is true for all X. Well, the only X we have, which is A. And over here, similar thing, Gx will be Ga, which is 1. Fy will be Fa, which is 1. So does there exist a y which Fy is true? Yes, it is true, because Fa is true. Now we have 1 arrow 1, which is 1. So is this arrow true for all X? Yes, it is, because there's only one row we have to look at. And is the negation, so the negation of that will be 0, and the negation of that will be 1. So I've got this formula true, this one true, and this one true as well. And that's what we wanted. We've got the two premises and the negation of the conclusion are true altogether. So this model that we've provided is a counterexample to this argument. So the answer to the question, is this argument valid, is no, it's not valid, and the counterexample is this one.